World's largest arthropod lived 300 million years ago. Now, fossils show what it really looked like. For nearly 2 centuries, scientists have tried to solve an enduring mystery about a giant millipede-like animal named arthropod that used its many legs to roam Earth more than 300 million years ago. Now, 2 well-preserved fossils of the creature unearthed in France have finally revealed what arthropod's head looked like, providing insights into how the giant arthropod lived. Today, arthropods are a group that includes insects, crustaceans, arachnids such as spiders and their relatives, and the extinct arthropod remains the largest known arthropod ever to live on the planet. Scientists in Great Britain first found fossils of arthropod in 1854, with some adult specimens reaching 8.5 feet, 2.6 meters long. But none of the fossils included a head, which would help researchers determine key details about the creature, such as whether it was a predator similar to centipedes, or an animal that merely fed off decaying organic material like millipedes. In a quest to find the first complete head, researchers conducted an analysis of arthropod fossils belonging to 2 juvenile individuals uncovered in the 1970s in France. The findings were published October 9th in the journal Science Advances. The odd tale of arthropod gained a new twist when the study team scanned the fossils, which are still trapped in stone. The head of each animal showcases characteristics belonging to both millipedes and centipedes, which suggests that the 2 types of arthropods are more closely related than previously believed, according to the study authors. By combining the best available data from hundreds of genes from living species in this study, alongside the physical characteristics that allow us to place fossils like arthropod on evolutionary trees, we've managed to square this circle. Millipedes and centipedes are actually each other's closest relative, said study co-author and paleontologist Dr. Greg Edgecombe, an expert in ancient invertebrates at London's Natural History Museum, in a statement. A time for giants. From the fossils and tread-like tracks arthropod left behind, scientists determined that the massive creature lived between 290 million and 346 million years ago in what's now North America and Europe, and it was just one of many giants roaming the planet. An abundance of atmospheric oxygen caused creatures such as scorpions and now extinct dragonfly-like insects called griffinflies to reach enormous sizes that dwarf their modern counterparts, the study authors said. But arthropod still stood out, reaching about the same length as modern alligators, lead study author Michael Laradier said. Laradier is pursuing his doctorate in ancient myriapods, an arthropod group that includes millipedes and centipedes, at Francis Claude Bernard University Lyon 1 to understand how arthropods adapted to live on land millions of years ago. Once the animals died and became buried in layers of sediment over time, some of them became entombed in a mineral known as siderite, which solidified and formed a nodule around the remains. Becoming encased in stone helped preserve even the most delicate aspects of the fossilized creatures. Such nodules were first spotted at a coal mine in Mont-Saint-Lès, France, in the 1970s, and then were transferred to French museum collections. Traditionally, we'd split open the nodules and take casts of the specimens, Edgecombe said. These days, we can investigate them with scans. We used a combination of micro-CT, microcomputed tomography, and synchrotron imagery to examine the arthropod inside, revealing the fine details of its anatomy. An intriguing arthropod ancestor. The 3D scans revealed 2 nearly complete specimens of arthropod that lived 300 million years ago. Both fossilized animals still had most of their legs, and one of them had a complete head, including antennae, eyes, mandibles, and its feeding apparatus. The first arthropod head ever documented, Laradier said. The team was surprised to uncover that arthropod had body characteristics seen in modern millipedes, such as 2 pairs of legs per body segment, as well as the head characteristics of early centipedes, such as the positioning of its mandibles and shape of its feeding apparatus. The creature also had stalked eyes, like crustaceans, Laradier said. In addition to helping researchers better understand what arthropod looked like, the discovery also draws a closer evolutionary connection between modern millipedes and centipedes. Previously, Scientists thought the two arthropods had a more distant relationship, but in recent years, genetic studies have shown that millipedes and centipedes were more closely related. This new scenario was criticized on the fact that there was no fossil or anatomical argument to defend this grouping, but our new findings on Arthropluera that combine features of both groups tend to confirm this new scenario, Laradier wrote in an email. Researchers believe the two Arthropluera fossils belong to juveniles because they reach just 0.9 inch, 25 millimeters, and 1.5 inches, 40 millimeters long. Studies of Arthropluera specimens have shown that the animals vary in the amount of body segments they have, similar to most millipedes that add body segments until they reach a fixed maximum. But centipedes have all their body segments already in place at birth, according to the study authors. This finding suggests that Arthropluera attained peak segmentation as an adult rather than at birth. But the researchers are curious to determine whether they found true juvenile specimens or a previously unknown smaller species, as well as the growth rate over time for such an animal. Tracks found elsewhere in Montceleste mines suggest that these Arthropluera were probably around 40 centimeters, 1.3 feet, at their longest, Edgecombe said. While there's nothing to say that they couldn't be bigger, we don't currently have any evidence of this. What Arthropluera ate and other mysteries. Now that researchers have uncovered a complete Arthropluera head, they hope the discovery can help them solve other riddles about the giant animal, including what it ate and how it breathed. But other fossils that preserve additional aspects of the arthropod's body, including the head of an adult, will need to be found. While definite gut contents are yet to be found, other details of these fossils contribute to the debate over Arthropluera's diet, Edgecombe said. They don't have any venom fangs or legs specialized for catching prey, suggesting it probably wasn't a predator, as its legs are better suited for slow movement. They were probably more like the detritus-eating millipedes alive today. Laradier, who is studying another group of ancient myriapods that may have been amphibious, said he is curious about Arthropluera's stalked eyes. Today, stalked eyes are a typical feature of aquatic arthropods like crabs or shrimps, he said. Could it mean that Arthropluera could have been amphibious? To answer this, we need to find the respiratory system of Arthropluera. Finding these organs can help us understand the link of Arthropluera with water. Gills like crustaceans would mean an aquatic/amphibious lifestyle, while tracheae, like insects or other myriapods, or lungs like spiders, would mean a terrestrial lifestyle. But unraveling what Arthropluera's head looks like solves a key mystery, said James C. Lamsdell, Associate Professor of Geology at West Virginia University, in a related article that appeared in Science Advances. Lamsdell was not involved in the new study. These remarkable findings, based on two almost complete juvenile individuals, present a new view of this enigmatic arthropod, Lamsdell wrote. The most exciting discovery comes from the specimen's heads that bear a mosaic of millipede and centipede characteristics. As the mystery of the affinities of the largest known arthropod is laid to rest, the work of reconstructing the life history of this exceptional creature can finally begin.